Introduction. What is cache? A temporary storage layer that holds frequently accessed data to improve system performance, while replacement is needed, because when the cache is full, the new data needs to be loaded. A replacement algorithm decides which data to evict. Introduction to LFU. LFU is a strategy that evicts the least frequently accessed data, based on the assumption that infrequent use in the past indicates less likelihood of future use.
Explain about what is LFU. LFU is stand for least frequently used, and it is a cache replacement algorithm that evicts the item with the lowest access frequency. Next, how is LFU works? First, it tracks how often the item in the cache is accessed, and items with the least frequency are replaced when the cache is full. And for the last, for assumption, data that is used less frequently in the past is less likely to be used in the future. That's all from me. Thank you.
Now that we know what is LFU, there are 4 ways how LFU works. First, it maintains frequency counters. This means each cache item has a counter tracking how often it is accessed. Second, on cache access. There are 2 types of cache access. First, cache hit. It will increment the frequency counter for the access item. Second, cache miss. It will check for the space. If space is available, then it will add the new item with an initial frequency of 1. If cache is full, it will evict the item with the lowest frequency. Third, handle ties. If multiple items have the same frequency, it will use a secondary criterion such as FIFO, does evict the oldest item, or LRU, which evict the least recently used item. And last, update cache. It will add the new item and set its frequency counter to 1.
Hello, so right now I'm going to explain about the next slide, which is example access sequence. So let's walk through the example provided, which is cache A, B, A, C, A, B, D, E. We will assume a cache size of 3. So step-by-step explanation, there will be 8 steps ahead. So let's begin. So for example, access A, cache miss is not in the cache. We will add A to the cache, and then there will be A in the cache. And then access B, cache miss B is not in the cache, and then we will add B to the cache, and then cache will have A and B. Access A, cache hit A is already in the cache. Therefore, increment A's frequency count. Therefore, cache will be A and B. And then we go through access C, which is step 4. Cache miss, C is not in the cache, but now cache is full. So, we need to evict something. LFU chooses to evict B. And then we will add C to the cache. Therefore, cache will have A and C. Access A, cache hit A is in the cache, increment A's frequency count, and then there will be cache A and C. And then we go to step 6, which is access B. Cache miss, B is not in the cache. Cache is full, so we need to evict something. LFU will be chooses to evict C, add B to the cache, and then cache will be A and B. Access D, cache miss, D is not in the cache. Cache is full, so we need to evict something. LFU is chooses to evict B, add D to the cache, and then cache will be A and D. The last step, access E. Cache means E is not in the cache. Cache is full, so we need to evict something. LFU chooses to evict D, and then add E to the cache. Therefore, cache will be A and E. So for the result, the final cache state is A and E. A and E remain in the cache because they will access more frequently than B, C, and D. So that's all for the example of access sequence. Thank you.
So this advantage and disadvantage of LFU. So the advantage is firstly efficient for frequently accessed data. It retains item accessed most often, ensuring frequently needed data stays in the cache. So second is predictable performance. It works well for applications with consistent data access patterns. Thirdly, it fair resource allocation. It gives priority to items based on their actual usage frequency rather than recency. Number 4 is optimized for static data patterns. It performs efficiently when the access frequency data remains stable over time. So the last for advantage is less dependent on access order. It focuses on frequency rather than when an item was last used, making it effective in specific workloads. So the disadvantage is firstly high computational overhead. It requires maintaining and updating frequency counters, which adds complexity and processing time. Secondly is slow adaptation to access pattern changes. It struggles when previously frequently used items are no longer relevant. Number 3 is still data retention. It might keep old, frequently access items that are no longer needed, wasting cache space. Number 4 is handling ties. Resolving ties between items with equal frequency can be challenging and require additional logic, FIFO or LRU. So the last one is memory overhead. Tracking frequency counter for each cache item consume extra memory, especially in large cache.
Third, we can use LFU for long-term frequency, and we can use LRU for short-term recency. So that is a hybrid model. We can combine LFU and LRU for better adaptability. So the third performance that can improve LFU is approximation techniques. We use approximation techniques to approximate frequency counts instead of exact tracking to reduce computational and memory overhead. So that is approximation techniques. Number 4 is adaptive LFU. So adaptive LFU is dynamically adjust the replacement criteria based on workload or application behavior. So lastly, the last type to improve our LFU performance is we use frequency caps. So frequency caps is usually we set a maximum frequency limit to avoid counters growing indefinitely and consuming resources. So that is 5 type of steps to improve our least frequently used performance. So that's all for me. Bye. Thank you.
In conclusion, the least frequently used cache replacement algorithm is an effective method for managing cache in environment where data access patterns are relatively stable and predictable. By prioritizing frequently accessed data, LFUs help optimize system performance. However, it has limitations such as difficulty adapting to change in access pattern and higher computational costs. To overcome this challenge, various optimizations such as decay mechanism and hybrid model can be employed. Ultimately, while LFU is used in certain scenarios, its performance can be enhanced by understanding the specific workload characteristic and apply the right improvement.